everyone, it's Mr. B and I'm back with another video. Today we're going to be talking about seafloor spreading. Alright, so let's get into it. Our buddy Alfred Wagner makes an appearance and is an important figure in seafloor spreading because we learned previously that he was responsible for the idea or thought up the idea of Pangea, or the idea that the continents were once grouped together and have slowly been separating apart, and so his ideas were not always approved and thought of as being correct, and so he gets a little help from his buddy Harry Hess, and so we'll talk about him in this section. In the bottom left-hand corner, by the way, that is Alfred Wagner right there. On the left side, we have ocean floor, and this is the deep ocean floor, and you can see that there is something happening in there which we're going to talk about in this section. Alright, so this is chapter 1, section 4. Let's get at it. Alright, so seafloor spreading. Deep within the ocean, the temperatures are near freezing, which we probably have a good idea of because the sun does not reach the bottom and it is extremely cold down there. There's no light, and living things are pretty scarce. We don't see many things that are down there. Yet there are some areas of the deep ocean floor that are thriving or teeming with life. The ocean floor sinks through cracks or vents in the crust, and so this ocean water is going to sink in there through those cracks or vents in the crust. The water is heated up and with the contact of hot material from the mantle. That hot water then is spurted back into the ocean. Alright, so we start to see that it's kind of this geyser that's happening inside of the ocean. There are organisms that are found there, such as the red-tipped tube worm. That should be worm, not works, Mr. B with the typo. Giant clams, spider-like crabs are all some of the organisms that are found towards the bottom of the ocean near these geysers, so to speak. And this idea of seafloor spreading is going to provide evidence for Alfred Wagner's hypothesis. Alright, so let's continue on. Alright, so this on the left side is a map of mid-ocean ridges. You will see that there are going to have some trenches that exist, and there are going to be some of these mid-ocean ridges. And mid-ocean ridges are undersea mountain chains where new ocean floor is produced, and it's going to be along a divergent plate boundary. Alright, so if you don't understand what a divergent plate boundary is, because we haven't talked about it too much yet, understand that it's basically an underwater mountain where our new ocean floor is going to be produced. Now, long time ago, in the 1900s, there were scientists that mapped the mid-ocean ridges using something that is sonar. Now, if you have any family that fishes and has a fish finder on their boat, you know that that is a sonar device. And a sonar device is a device that bounces sound waves off underwater objects and then records the echoes of the sound. Alright, so the closer you are to the object, the faster the sound is going to come back. The further away you are, the further or longer it's going to take for that to happen. And so through this process, they were able to figure out that there are a bunch of shallow areas and a bunch of deep areas, and it helped to map out mid-ocean ridges. Alright, mid-ocean ridges, if you've ever held a baseball before, it's very similar to the seams of the baseball that are along there. So they're very similar to the ocean floor being the ball. The seams that are on the baseball are going to be the mid-ocean ridges. Most are hidden under hundreds of meters of water. There's only a few places that poke up above the surface. So if you look where the island of Iceland is, that is an example of a mid-ocean ridge which has come above the surface. Mapping these mid-ocean ridges made scientists curious. They were curious, what is causing these mid-ocean ridges to occur? Let's take a look and see what it is that does cause them. Well, they discovered this idea of seafloor spreading, right? And so, while you can't necessarily see right away that this guy right here is a famous scientist or geologist. His name is Harry Hess, and he was the scientist who studied mid-ocean ridges, and he looked and thought about the ocean floor in relation to Alfred Wagner's idea of continental drift. And he concluded that maybe Wagner was right all this time and that the continents are moving. But what was causing the movement of the continents? Well, Hess suggested that it's actually the sea floor, or the ocean floor, that's moving. So the seafloor spreading idea is that the seafloor spreads apart along both sides of mid-ocean ridges as new crust is added. As a result, the ocean floor moves kind of like a conveyor belt, carrying the continents along with them. So here's a continent, and it's slowly moving along because of this ocean floor. Seafloor spreading begins at mid-ocean ridges, which forms along cracks of the oceanic crust. Alright, so we know that seafloor spreading is along the ridge, molten material that forms several kilometers beneath the surface rises and erupts. So if you look down here, you'll notice that there is the mantle, which has our molten material that's going to come up, and it is going to flow out and over. And along those, at the same time, the older rock, so the older rock is going to get pushed away, and it's going to move outward on both sides of the ridges. So on this side over here it's going to move, and then over here as well it's going to move. As molten material cools, it forms strips of solid rock in the center of the ridge. When more molten material flows into the crack, it forms a new strip of rock. Alright, so this is constantly releasing and releasing out this way and moving. And when I say constantly, that's probably a way overstatement. These are taking tens of thousands of years to release and make the ocean floor move. That's why we've seen the continents slowly move over time. This isn't something that happens overnight. So what evidence do we have? As scientists, we're always looking for evidence to support what is actually happening. So what evidence do we have for seafloor spreading? Well, there's a bunch of evidence. This evidence supported Hess's theory of seafloor spreading. His evidence, the first one, was that there were eruptions of molten material. And this evidence of new material is indeed erupting along mid-ocean ridges. Elvin, pictured right here, is a small submarine that found strange rock shapes like pillows or toothpaste squeezed from a tube that was down at the bottom of the ocean. And such rock can only form when molten material hardens quickly after erupting. This happened again and again, that they noticed when they came across some of these mid-ocean ridges that there was these weird or strange looking rock shapes that were only near them. So that was one thing that Hess had to support his theory. The next one was evidence of a magnetic strip in the rock of the floor. Now, scientists discovered that the rock that makes up the ocean floor lies in a pattern of magnetized strips. These strips hold a record of reversals in Earth's magnetic field. The rock of the ocean floor contains iron. The rock began as molten material that cooled and hardened, and as the rock cooled, these bits of iron inside of them lined up in the direction for Earth's magnetic poles. Using sensitive instruments, scientists were able to record the magnetic memory of rocks on both sides of the mid-ocean ridge. Now, if we quickly buzz back here to this picture, you'll notice that there are some of these strips that are going this way, and there are some that are going this way. That helped with the idea that they found the strips to form when Earth's magnetic field pointed north, which is the alternate with stripes of rock that formed within the magnetic field point itself. And so Earth's magnetic poles have reversed themselves many times during the course of history. Now, that is a lot of information. What is the main take-home message that you need from this? Well, understand that there is iron that is in this molten material that is going to harden. And over time, what's happened is that some of them have been found in different spots and in different locations. And that helps us to understand that they've been changed slightly based on our magnetic poles. Right? So that's supported in a very deep way of the seafloor spreading concept. Another one is going to be the fact that there are several types of evidence that were there, and this was kind of like the final moment when Hess's theory supported Wagner's theory. And what it was is the fact that they were able to drill into the sea floor. And by drilling into the ocean floor, they were able to determine the age of the rock using those samples. And they found that the further away from the ridge the samples were taken, the older the rock. The younger rocks were always in the center of the ridges. Alright, so let me bring this back and help you to understand what that means. So imagine that if this is where the newer rock is formed, we would expect that this would be when they take the sample newer rock. The material that was further away from it, this would be older rock. And according to what the information said, that was absolutely true. Now, subduction of trenches. Alright, how can the ocean floor keep getting wider and wider? The ocean floor generally does not keep spreading. It's actually the ocean floor plunging into deep underwater canyons called deep water trenches. Deep water trenches cause the oceanic crust to bend downward in a process that takes tens of millions of years, and part of the ocean floor sinks back into the mantle at deep ocean trenches. Alright, so what we have is we have this oceanic crust, which is essentially getting shoved down into the trenches, and then that part gets heated back up and will become the molten material, which will form and again release through our mid-ocean ridges. So we kind of have this circular pattern that is happening of the sea floor getting shoved back down as the older rock gets shoved back down into these trenches, where then it goes into the mantle, gets heated up, and starts the process over again. The process of subduction, the process by which ocean floor sinks beneath a deep ocean trench and back into the mantle, is called subduction. So that crust getting pushed down, that is subduction. The crust that is closer to the mid-ocean ridge moves away from the ridge towards a deep ocean trench. So it's that conveyor belt idea. It comes up, it moves, and then it gets shoved down as a process called subduction. Seafloor spreading and subduction work together, moving the ocean floor as if it were a giant conveyor belt. And that's also where our continents sit. They sit on these plates that are constantly moving. New oceanic crust is hot and cools, which becomes more dense and moves away from the mid-ocean ridge, and then eventually pulls this older, denser oceanic crust beneath the trench. Long-winded answer to that: the ocean floor is slowly moving, and when it gets to a point where it gets to be at a trench, it gets shoved down into that trench, gets heated back up, and it cycles through it. That is subduction. Okay, here it is again. We have our molten material that's going to come up, and it's going to release in both directions. This is going to be the newer rock formation that's going to happen. It's going to look as Hess noted, pillows that look as though they're here, or a toothpaste that is squeezed out. And so these are the areas that are new rock, and what's going to happen is that they're slowly going to be moving as more and more of this gets put out, and eventually it's going to get shoved down into a trench, which we call subduction. Then in return, that's going to get heated back up in the mantle, because we know that the deeper inside of Earth you go, the warmer it's going to get. Again, that rock's going to get heated up and released, and it's going to keep happening. Looks kind of similar to convection currents from what we talked about earlier this year. The process of subduction and seafloor spreading can change the size and shape of the ocean. The ocean floor is renewed about every 200 million years. That's a long time. That's a long, long time. It's going to be not in our lifetime that we're going to see this happen. That is the time that it takes for the new rock to form at the mid-ocean ridge to move across the ocean and sink back into the trenches. Alright, so that is Chapter 1, Section 4. Make sure you understand that Wagner's ideas were proved to be correct because of Harry Hess's understanding of seafloor spreading. This idea that there are mid-ocean ridges, they heat up, release out material, that spreads apart, pushing the old rock away, and then eventually that gets shoved back down into the trenches where it gets heated back up again. Alright? If you have any questions, let me know. Otherwise, we'll talk to you soon.